Alright, in this video we're going to be talking about radicals, what radicals are and the rules regarding radicals so that we can manipulate problems and solve for things. And the rules that we're going to be talking about are on page 4, the second half of page 4 within the study guide. So if you want to follow along, get the study guide out and go to the second half of page 4. But before we start talking about those rules, I want to talk about what a radical is and what we're actually doing with it. So I'm going to write down an example here, and I'm going to write down the cube root of 8. And a quick side note, and this is actually the first rule within the book, is that if we just have a radical, and this is what a radical is, it's just this symbol here, and I just say of 25, let's say, if there's no number over here, then it's assumed to be 2. When it's 2, we don't write anything down. So when we talk about the square root of, say, like 25 that I just wrote down, there's actually a 2 right there that we don't write down. But let's talk about what it all means, and over here I actually have a 3. Well, what I'm saying when I'm writing down a radical with a 3 there like that is that I'm asking you what number multiplied itself by itself this many times, so 3 times, is equal to this number in here, will give us this number as a result. So what number times itself 3 times gives us 8, right? And if we think about it a little bit, then we can say, well, 2 times 2 times 2 is equal to 8. 2 times 2 is 4, times 2 is 8. And so the cube root of 8 is equal to 2. Another example is if I say, let's talk about the square root, right? And so, like I said with the square root, there's an assumed 2 that you're not going to see there. The square root of 25. I'm asking you what number multiplied by itself 2 times, exactly by itself 2 times, is equal to 25. And we know that's 5 times 5 is 25, so we say that it's 5. And if you're watching this video, then you might say to yourself, well, what about negative 5? And of course, negative 5 multiplied by negative 5, we have negative 5 times negative 5, that's actually equal to 25. And so the square root of 25 is actually equal to plus or minus 5. But within this book and with this test, you're actually not going to be dealing with negatives as far as plus or minus. You're not going to be seeing that too much in this book. So I would encourage you just to look at the positives here. The reality is if you got asked a question and they asked you for the square root of 25 and it was multiple choice and it said negative 5 was one of the answers, well, that's correct. So don't disregard it completely, but you won't probably see it too much on a test like this. And not to fill your head with stuff that you might not use, because you won't see this either, but this rule here is also why we will never see within an even root here, so it could be a 2, it could be a 4, you'll never see a negative within that. That cannot happen. And as you get a little bit farther in math, that's where imaginary numbers come in. But think about it for a second. If I just say, let's say that's a 2, the square root of, let's say, negative 25, is there any possible way where I can multiply some number by its exact duplicate and get a negative number, negative 25? As we just saw, if I multiplied negative 5 times negative 5, I get a positive 25. And then a positive 5 times a positive 5 is also 25. And so the only way we can get a negative 25 is if we multiply negative 5 by a positive 5. And that breaks what a radical wants you to do. It wants the number to be identical to itself. And so if you have an even number right here, you cannot get a negative within the radical there. And I say even because let's talk about, let's say, a cube root. What if I say the cube root of, say, negative 8? Well, I can get that, because what if I do negative 2 times negative 2 times negative 2? Well, negative 2 times negative 2 is, of course, positive 4, times negative 2 is then negative 8. So if this number here is an odd number, we can in fact get a negative number inside of here. All right, let's move on to the next rule. The next rule talks about breaking up a radical, and there may be reasons why you want to do this, and we'll show you one. But it basically says that if I have the root, and they use an n here, just meaning any real number. If I have, let's say, a times b, so more numbers, then I can break it up into the nth root, so any number, let me put a 2 there or a 3 or whatever, of a multiplied, and I break it up, and this also has to be the nth root, of b. So I can just kind of separate them. And just like I can separate them, I can also bring them back together. So if I have something like this over here, I can combine them as long as the n is the same here. So let's look at a reason why we would want to separate them. If I have something like, let's say, the square root of 50, well, I could say that that is the same as the square root of 25 times 2. I'm just breaking up that 50. Now I can separate that and say, well, that's the same thing as the square root of 25 times the square root of 2. And I know the square root of 25. I know the square root of 25 is 5 and multiplied by the square root of 2. And so this is actually a more correct answer, even though it's a little bit more spread out than this one. And so that's the reason why we do that. Now if you have a calculator, you would just hit the square root of 50 in your calculator and you would get some decimal. And that's okay. But on this test, you're not going to have a calculator. And so if you're giving something like the square root of 50 over here and they ask you to simplify it, this would be the correct path to do that. And the correct answer would be 5 times the square root of 2. And like I said, if you have, say, the square root of 5 times the square root of 2, I could simply combine those two into the square root of 5 times 2, and that's the square root of 10. And we would leave it like this because I can't really pull out the 5 or the 2. I'm not going to pull out a decimal, and you're not going to be expected to do that on the test. And so a simpler version of this right here would be just the square root of 10. All right, so now I'm going to scroll up a little bit. And the next rule we're going to talk about is actually one that we saw in the exponents video. And that's basically just saying that if I have something like, let's say, the cube root, and I could do this with square, cube, or anything, the cube root of, say, 8 over 27, then we saw it in the exponent videos, but we could just play it out like a normal exponent, multiplying the fractions, but it gets a lot harder to do that here with radicals. But when I can separate this, just like I do with exponents, if I can separate this, I can say, well, that's the same thing as the cube root of 8 divided by the cube root of 27. And then we can look at these and we can say, well, the cube root of 8 I know is 2, because 2 times 2 times 2 is 8. And the cube root of 27 is 3, because 3 times 3 is 9. Times 3 is 27. And so our answer would be 2/3. Whereas when we look at it over here as the cube root of 8 over 27, it gets really hard to think that, just doing it like that, I can think that the cube root of 8 over 27, I don't know what it would be. But when we separate it, it becomes much easier to see. So let's go on to the next rule. That becomes very, very handy at times. And I can do it, just a quick recap, I can do it the same thing if I had just this square root of, say, 16 over 9. I could say, well, that's the same thing as the square root of 16 over the square root of 9, and the square root of 16 is, of course, 4. The square root of 9 is, of course, 3. And so then our answer would be 4/3. And again, any question that they ask you on here, it might be kind of tough. Like they might say the square root of 49 or 64, 81. It should be a whole number. It will be a whole number. I can guarantee you that. Or you will just leave it as, say, the square root of 10, like we did up here. I'm not going to ask you the square root of 10 and expect you to give me an answer because you don't have a calculator and I'm not going to be able to use this one on the test. However, you will want to know all your perfect squares, so like the square root of 16, of 9, of 25, up to 10, so the square root of 100, as well as the cube root of a few, and the highest I've seen, I think, is the cube root of 27. So I would get familiar with the cube root of 8 being 2, as we saw here, and the cube root of 27 being 3. The cube root of, let's see, 64, I almost wrote 65 there, is equal to 4, because 4 times 4 is 16 times 4 is 64. But I don't think that's going to be on the test anymore. I haven't seen it. So I would just get comfortable with the cube root of 8 and the cube root of 27. And then a lot of square roots, all your perfect squares. All right, let's move on to the next rule. And the next rule is just a little, I mean, this is all really just notational stuff, but it's, a lot of people don't realize this. If I write, let's just say the cube root of, I don't know, 8. Anything to the 1 power, and I'm going to write this over here. I'm going to just write like 5 to the 1 or x to the 1. Anything to the 1 power is just itself, right? So 5 to the 1 would just be 5, and x to the 1 would just be x. And we don't write that 1 there. It's, you know, it's just extra information. I kind of talked about that in the previous exponents video, but it's there if we need it there. So I could write a 1 right there next to the 8. And the reason I'm going to do that is because I could rewrite this, the cube root of 8, as an exponent. That's the 8 to the 1 over 3, the 1/3 power. This number in here goes up top, and then this number over here goes on the bottom. And so you won't see anything like this, but if I had like the 4th root of x to the 5th, let's say, I could rewrite that as x to the 5 over 4. But you will see something like this. If I have the square root of, let's say, 25, that's equivalent to 25 to the 1/2 power. And this is good to get used to, not only for this test, but when entering things into your calculator, when you're in a class and you have a calculator, if you want to take, say, the 9th root of something, you want to use it as an exponent. So it's good to get used to this kind of notation, to be able to work back and forth from that notation there. And it also becomes essential when I say something like, well, what if I said the x squared is equal to 25? Now you might look at that and you might say, well, it's 5. I know that, I can see that. But how do we get there? Well, we want to get rid of this exponent here. We want to get it in such a form that we just have x equals, right? So x equals some number, right? X squared equals 25 doesn't really help us. So we need to get rid of that squared somehow. And the way we do that is that, I'm going to write it again over here, x squared. The way I do that is I take the root, right, with the equivalent power here, as the equivalent number there, the n there, so they're the same. Because if that's the case, and if I have a 2 here and a 2 there, and I don't write this 2, but if they're the same, then I can rewrite this as x to the 2 over 2, which is equal to x to the, well, 2 divided by 2 is just 1, which is equal to just x. Like I said, now we just have x. And that's actually the last rule on this page. If you look down there, n over n is just 1. And so if I took the square root of this x right here, then I would get x, the square root of that x squared, excuse me, I would have x. And then, again, all mathematics basically says that I can do whatever I want to one side of the equation as long as I do the exact same thing to the other side of the equation. And so I would have to take a square root of this 25 here. And then we talked about earlier, the square root of 25 is 5, essentially, or you could say plus or minus 5, but for the purpose of this booklet, it's just 5. And so one more example over here. If I have something like, let's say, x cubed is equal to 8, let's say, then just like I did before, I'm going to take the radical, right? But I want to take the radical that's equal to this power in here, right? So I'm going to take the cube root. And again, if I had the cube root, so I have x cubed and then the cubed root, right? This would equal to x to the 3 over 3, which is just x to the 1, or just x, like we just said with the 2. And so if I take the cube root of x cubed, I get x. And then again, I have to do the exact same thing to the other side of the equation. And so I would take the cube root of 8, and the cube root of 8, as we discussed before, is just 2. And so this rule over here, this rule that says we can rewrite the radical in an exponent form, a fractional exponent form, is very helpful when we start solving for x, which we'll be doing later on. I don't think you'll be doing the cube root much, but you will definitely be using the square root a lot. And so taking the square root of x to understand why we do that and how we get just x out of that is important to understand. And that is the last of the rules that I'm going to go over. In the next video, we're going to be doing the examples. And if you do have any more questions about any more radicals, they are very confusing. So please don't hesitate to come in and ask any questions. Come into the tutoring center, or by all means, comment below with any questions that you might have, or anything that I might have missed. But I will see you in the next video. All right, welcome back. In this video, we're going to be going over the example problems of the radical section, which is on page 11. And I'm going to be doing all the odd problems in this video, and I'll leave the even problems to you. If you feel like you need help, by all means, come into the tutoring center and get some help. All right, so let's get started. Number 1 says, the square root of 2 times the square root of 15. And it just wants you to simplify this problem. Right? We can't, it's not going to ask you for an actual number because you don't have a calculator. So what we're going to do is we're going to say, based on the rules that we talked about in the previous video, I'm going to combine these two under the square root of, and then I'm going to say 2 times 15. So I'm just going to move those under the same root symbol. And then as I move those under the same root symbol, I'm just going to multiply the 2, and 2 times 15 is simply 30. And so my answer is simply the square root of 30. And that's just simplified from what it is over here. And if you look in the back, it says that the answer is either the square root of 30 or 5 root 3. And I'm telling you that there is absolutely no way that you should be able to get from the square root of 30 to this answer over here. So this is absolutely, without a doubt, not correct. We need to correct that in our booklet, and we should be doing so. But at this time, that might be in the back as well. But the correct answer is just the square root of 30, and there's no simplifying going on after that point. All right. So, like I said, I'm going to do all the odd problems. So let's jump straight to number 3. And number 3 says negative, and then it says square root 25 over 36. And the hardest thing, and hopefully it's not too hard, but the hardest thing about this problem is just realizing that the negative is on the outside of our radical. And so, like I said in the previous video, our rules say that we can separate this and say that that's just 25, the square root of 25, over the square root of 36. And then again, you should be comfortable with saying that the square root of 25, there's still a negative symbol there, the square root of 25 is 5, and then that the square root of 36 is 6. And so our answer is just negative 5 over 6. Again, the square root of 25, that could be plus or minus 5. Square root of 36 could be plus or minus 6. You could get a few different answers, but for this video, we're just talking about positive 5 and positive 6. And then the negative is still there, so our answer is negative 5 over 6. Moving on to number 5. Number 5 says, and this is pretty straightforward, 16 to the 2 over 8 to that power. Now you could do one of two things, and the easiest thing to do is to simplify that 2 over 8 first. And if I do that, then I have, well, that's just 16 to the 1 over 4. And if I do that based on the rules in the previous video, again, I could say that, well, that's the same thing as, I'm going to rewrite that as, well, there's a 4 here, and then a 16 to the 1 power. I'm not going to write the 1 power, but now I just need to look at what the 4th root of 16 is. And I said earlier that, you know, you should get comfortable with cube root of 8 and cube root of 27. Well, in this example here, it's the 4th root, but it's just, our answer is simply 2, so it's not too difficult to see that. And you shouldn't get much harder than that 4th root right there. They're not going to ask you the 4th root of anything too much higher. And as I say that, I look at problem number 10 and they ask you 81. But on the test, I don't think they're going to get that difficult as far as that. But again, it's not too difficult. As long as you think about what a square root is, or cube root, or a 4th root, what it is, and what they're really asking for, and then you just kind of test out some numbers to see what they are. And so we just see simply that the answer is 2, right? The other way we could have gone about that is, well, I could just rewrite it right away and said that, well, that's the same thing as the 8th root of 16 squared. And I don't know what 16 squared is. I can do it, write it out real quick, and I could try to figure out what the 8th root of that is, but I'm not going to do that. And so the point is that if you simplify this first, it becomes much easier. And the hardest thing you have to do is realize that the 4th root of 16 is simply 2. All right, so moving on to the next odd problem, let's look at number 7. And number 7 says the 6th root of negative 5 to the 6th power. And if you were watching the previous video explaining radicals, I told you that if this was ever an even number, that we could never get a negative. And this is just kind of a loophole around that to kind of get rid of that sometimes. You probably won't see a problem like this, but in a little bit higher math, you may use, not maybe to the 6th power, but you may use this rule to kind of get rid of that radical for different reasons. But here, let's just, before we say that we can't do it, let's try rewriting it. I could say that this is the same thing as negative 5 to the 6th over 6th. The power comes up here, and then the radical number comes over here. And then we just say, well, 6 divided by 6 is simply 1, and so this is just negative 5 to the 1 power, or just negative 5. And so the answer in the back is negative 5, and that's how that comes to be. And I don't think you'll see that too much, but if you do go on, you may learn that later on. All right, and finally, the last odd problem for this section. These haven't been too difficult if you watch the previous video. These shouldn't be, nothing should come as a major surprise to you. This one's, it's a little tricky when we look at it. And it says the square root of 7 plus 5 times the square root of 7 minus 2 times the square root of 7. And again, you're not going to have a calculator. I'm not expecting you to actually take the square root of 7 and do all the math, as far as calculations through a calculator go. But if we can imagine for a minute that instead of the square root of 7, I'm going to replace that with x. And so I'm going to say x is equal to the square root of 7, right? And so since these are all the same, this square root of 7 here, this square root of 7 here, this square root of 7 here, it becomes, well, if I substitute that, I'll have x plus 5 times x minus 2 times x. And this might be a little bit more comfortable with you. And so we just have x plus 5x, and we'll get into this a little bit more, with variables and stuff in later sections. But, x plus 5x is simply 6x minus 2x is simply 4x. And then if I replace that x back in there, it's 4 times the square root of 7. And the only reason I substituted was to make it a little bit more comfortable for you to see that as long as these are all the same, we can just treat these as objects. I have one of these objects, it's the square root of 7. I can call it, hippopotamus. And then I have plus 5 of those, and then minus 2 of those, right? As long as they're the same power and the same number in here, they're all the same. So they're just objects. And so if I replace those with x, it's a little bit easier to see. I have x plus 5x minus 2x. And then so my final answer is simply 4 times the square root of 7. Again, if you had a calculator, you can do that in your calculator and get some decimal number. But since we're not going to have that on the test, this is our most simplified answer here. It's 4 times the square root of 7. And that's the last problem within the radical section. If you're having any trouble with the even problems, please come into the tutoring center or comment below. You can comment below on a problem that I haven't done, or maybe if I missed something, one of the problems I have done, please ask below, and hopefully we can get an answer out to you. But again, I encourage you guys to come into the tutoring center, you guys and gals, to come into the tutoring center if you need any more help. I will see you in the next video.